All right, let's dive into a really fascinating aerodynamic force, one that every pilot feels, but you can't actually see. Think of it like an invisible cushion, one that can be a huge help or a pretty dangerous trap.
So have you ever been on a plane that's landing and it feels like it just floats? I mean, it just hangs there endlessly right above the runway, refusing to touch down. Or maybe you're a pilot and you've fought this yourself. What is going on there? Well, what's causing that mysterious float is this phenomenon that completely changes the game during the most critical parts of a flight.
Okay, so that floating feeling, it is absolutely not just in your head. It is a very, very real aerodynamic thing. And honestly, the reason it feels like you're flying on a cushion of air is because, well, you kind of are.
The name for this is ground effect, and yeah, that aerodynamic cushion is really the best way to picture it. See, when a wing gets super close to a surface, like a runway or even the water, the air underneath it gets all compressed and trapped, and that changes how the wing performs in some really, really big ways.
But, cushion is just a simple way to put it. So how does this whole thing actually work? To get our heads around ground effect, we first got to look at what a wing is doing way up at altitude. And the secret? It's all in the wingtips.
Okay, so basic aerodynamics, right? A wing makes lift because you've got high-pressure air underneath and low-pressure air on top. Well, nature always tries to balance things out, so that high-pressure air is desperate to get to the low-pressure area above. The only place it can do that is by spilling around the wingtips, and when it does, it creates these big, swirling tornadoes of air. We call those wingtip vortices.
Now, why does that matter? Well, here's the catch. These vortices create a powerful downward flow of air right behind the wing. We call it downwash. And this downwash actually tilts the entire force of lift backward, just a little bit. And that backward pointing part of the lift, it's not lifting you up anymore. It's just dragging you back. And that, my friends, is what we call induced drag.
All right, let's put it all together. Picture a plane way up high. Those wingtip vortices are huge, they're powerful, they're creating a ton of downwash, which means you've got a lot of induced drag. But when that same wing gets close to the ground itself literally gets in the way. It stops those vortices from fully forming, kind of squashes them flat. With smaller vortices, you get less downwash. And less downwash means way, way less induced drag. All of a sudden, the wing just becomes incredibly efficient.
And I'm not talking about a tiny little change here. We're talking about a massive difference. When an aircraft gets really, really close to the surface, its induced drag can be cut by up to 50%. I mean, think about that. The plane is suddenly way slipperier in the air, much more efficient, and the pilot hasn't touched a single control.
So the big question is, when does all this magic happen? Well, the general rule of thumb is that ground effect really starts to kick in when the plane's altitude is about the same as its wingspan. But here's the key. It gets way stronger the closer and closer you get to the surface.
So you can see how this huge change in performance means ground effect is something every pilot has to be super aware of. It's a real double-edged sword. In one moment, it can be your absolute best friend, and in the next, your worst enemy.
Let's talk about the trap first. Imagine you're landing, but you're coming in with just a little bit of extra speed. The moment you enter ground effect, your drag just falls off a cliff. And the plane, it just refuses to land. It'll float and float and float down the runway, just eating up all that precious asphalt you need to stop. It's the perfect example of why pilots are taught to be so precise with their approach speed.
And get this, the type of plane you're flying makes a huge difference. A low-wing aircraft, like a Piper Warrior, has its wings super close to the runway, right? We're talking maybe 10% of its wingspan high. Right before it touches down, its drag is slashed to just 40% of what it normally is. Now, compare that to a high-wing plane, like a Cessna 172. The wing is much higher up, so while the effect is there, it's way less dramatic. That's exactly why you hear pilots of low-wing planes talk about that floating sensation all the time.
Okay, but it's not all bad. Pilots are smart, and they've figured out how to use this force as a tool. Picture this. You're trying to take off from a soft field. Maybe it's muddy or just wet grass. The last thing you want is for your wheels to get stuck, so the goal is to get them off that sticky surface as fast as humanly possible.
And that's where this really clever technique comes in. So what a pilot will do is actually lift the plane off the ground early, before it's even going fast enough to climb. Then they immediately push the nose down and level off, flying just a couple of feet above the runway. Why? To deliberately fly inside that ground effect cushion. In that super low drag environment, the plane can pick up speed way faster. Once it hits a safe climbing speed, then they'll pitch up and fly away. It's just a brilliant, brilliant use of physics.
And you know what's really cool? This incredibly powerful principle isn't just for airplanes. No. Engineers have taken the power of ground effect and used it in some absolutely wild, high-performance machines, both on the ground and on the water.
Take a Formula One car. For all intents and purposes, it's an upside-down airplane. Its whole design is about using the ground to create this intense low-pressure zone underneath the car. So instead of making lift, it generates a crazy amount of downforce. It literally sucks the car onto the track. And that's the secret sauce that lets them whip around corners at speeds that just look like they should be impossible.
And then there's this absolute beast, the Ekranoplan. These were these gigantic Soviet vehicles designed with one single purpose, to fly only in ground effect. They would skim just a few feet above the water, taking full advantage of that massive drag reduction to haul enormous payloads at incredible speeds. I mean, they were part boat, part plane, and 100% pure ground effect.
So, as you can see from the gentle landing of a little Cessna to the mind-bending speed of an F1 car, ground effect is this powerful, invisible force that's constantly shaping performance.
All right, so let's do a quick recap. Ground effect happens within one wingspan of a surface. It's all caused by the ground messing with those wingtip vortices. The result? A massive drop in induced drag. For a pilot, it's a hazard you have to manage on landing, but a tool you can use on takeoff. And it goes way beyond planes. It's a key principle in motorsport and even marine transport.
When you really think about it, ground effect is just the perfect example of how understanding and, mastering these invisible forces of physics is the real key. It's how we push the boundaries of engineering, of performance, and of human skill.
And it really makes you wonder, right? As we get smarter and better at understanding the world around us, what other invisible forces are out there just waiting for us to figure them out and harness them in some totally new, revolutionary way? Something to think about. Thanks for joining me.